Hello and welcome back to video 3 in the developers forum. This is D3 and today we're going to be building a tree graph like you see on the screen before you. So we'll have a small bit of data, maybe 3 levels. One parent top level has 2 children, level 2A, level 2B. And then level 2 has 2 children as well. Level 2A has 2 children as well. So what we have here are nodes. We have links between the nodes, and then we have a path drawn highlighting or graphing that link. Okay, this is going to be an interactive graph. We're going to be able to click on each node that has children and expand and collapse it like so. Okay. We're going to code through this. There's a few things to take note of first. So we're going to be using d3.tree. Say that 10 times fast. So this creates a new tree layout with default settings. Okay. Lays out the specified root hierarchy, assigning the following properties on root and its descendants. So root hierarchy, we're going to pass our data into this and it's going to wrap it, our hierarchy. So if we go to all this information is on d3js.org. If we go to d3.hierarchy, so we pass our data into the hierarchy and constructs a root node from the specified hierarchical data. The specified data must be an object representing the root node. Okay, so we're going to pass our data into this and it's going to wrap it up in a way that we can use in our tree graph. Okay. This is our page today as we start. There's nothing on it, as you can see. So we'll move on over to our code. Again, we have our tree.html page. We have a container. We have our 2 links, one.html, which we don't use, so we'll actually just get rid of that. We had a what? Index.html. We're loading D3 version 6 from CDN from D3 itself. Okay, and then we're going to put our tree code into our tree.js file. Okay, so our data is we're just going to pop in some hierarchical data first to give you an idea. So we're going to create an object. Okay, we have our name. It's going to be top level. And it's going to have children. An array of children. So each child is an object. So it too has a name and it too has children. Possibly. Doesn't have to. Okay, so that's going to be an array as well. And another object. So now this one didn't have children. So level 2B. Okay, this will be level 2A, and level 2A will have 2 children as well. So these children will not have children, so they'll just have a name. So child of A. Okay, so son of A. Daughter of A. Okay, so this is our original data. This is like JSON. It's a JavaScript object, but this would be in similar format to what you would get when you loaded JSON into your application. Okay, so what are we going to do first? First, we're going to set up our SVG. Okay, so first things we do, we're going to, last time around with our circles were at the very edge of the graph, if you remember. So this time around, we're just going to put our margin in our SVG so that all the elements within the SVG are contained within the SVG, that they won't run off to the edge or they won't get cut off by the edge of the SVG. So we're going to set a margin as an object. So margin is going to have a top, right, bottom, and left. This will just contain our elements within our SVG. Okay, we're going to have a width and height. Okay. Okay. Yeah. This is kind of what we want, but we'll just go through it. There's a handy thing for VS Code D3 snippets, so when you're typing in this stuff, it will automatically populate your code for you. But just to show you what we're doing, we'll just type it out. So for our SVG, D3, where we want dot select, we have a container, so dot container because it's a class that we're selecting. Dot append SVG, give it a width, we're going to append a G here as well. So G element is just an element to group things together. Okay, so just the width and the height here, so we're taking the margins away from these so we can refer to the width and the height within our code without doing calculations on it. And then we set the SVG, so we add back in the heights and the margins. So we add back in our margins when we're creating our SVG. So our height and our width are contained fully within the SVG. Okay, so we're going to set up a couple of variables here. So I is equal to 0. We're going to set a duration for our transitions for our animation. So when you click on the tree, we're going to set a duration for that to move. So, and then we're going to create our variable root. So if you remembered from our documentation, oh, it's not there anymore. There was a root variable there that we passed into the tree graph. So okay, so now we're going to create a tree map variable. So d3.tree, give it a size, and we're going to pass in the height and the width. Okay, we're going to populate our root variable now. Root is equal to d3.hierarchy. Pass in our tree data. So pass this into our hierarchy and then run a function on that. So function, so return d.children. Okay, we're going to set the base x and y coordinates as well. So root.x 0 is equal to height divided by 2, and root.y 0 is equal to 0. So we're saying we should start, our nodes should start in the middle of our graph and over on the left. Okay, so just to give you an idea here now, we're going to log our root. So when we go to our page, we can refresh our page. Merging, okay, sorry now. Okay, we can see here, so our tree data up here, name top level, it's just an object with name and children and arrays of children. So that has now been wrapped here, you can see. It has the depth, the height, the parent, it has x0 and y0. Okay, it has children, it has data, and you can see our data here is what? Our original data, our tree data, but it's now been wrapped with a few extra parameters. And if you can go into your children, you can see that in here you can see in the children, you can see that they have a depth and a height as well. Okay, so passing in our data into this hierarchy wraps it in a new object and gives it extra variables that the tree uses to create our graph. Okay, we're going to be clicking on the nodes. Okay, we're going to be interacting with our graph, so we want the functions that we're going to define and the way we're going to draw it on the graph. We're going to create an update function so that all of those can be run quite easily. Every time we click on the graph, we'll update the whole graph. Okay, so we're going to wrap all our functions within an update function. Okay, so we'll start by saying update root, just to, because we've created our data, we've wrapped it, and now we want to update. So what does update do? Okay, we'll start off function update, and we pass in the source. So source being whatever you're passing in. Okay, our data. Our data at the start, when we first pass it in, it's root. But afterwards, as we go through, we call update with different sources, with new sources, with the data that's been updated. Okay, so for our tree data is equal to tree map, passing in our root. Okay, so we're redefining our tree data within the function, but because it's block scoped, it stays within that function. Okay, we're calling our tree map function and passing it in our root, our hierarchical data. Okay, so what do we need for our function, we need nodes, we need links, we need a path. Okay? So, nodes first of all. For nodes, tree, data dot. Any questions or any queries about these functions, all the information can be found on d3js.org. Okay, so we're going to normalize the nodes as well, so for a fixed step, so that when our graph is done, that the nodes perform and are situated in the same kind of place and it looks nice. So we're going to loop through our nodes, nodes.forEach function, and our usual d, we're referring to the datum here that we're passing, so for each node, so d.y, we're going to set the y value is equal to d.depth multiplied by 180. So we saw our children had depth, so we're just using that depth to set the y value on the nodes so that they're contained nicely within the graph. So we're going to want to update our nodes. So for our node, I'm going to add them to the graph. That's svg, that's select all. Okay, so we're selecting all here, not just selecting one, we're selecting all the nodes. We're passing in our data, and then we're calling our callback function. So returning d.id, or if it has a child. Okay, so any nodes now, when we saw in our graph, when we clicked on our nodes, they started at the position of the parent and then they transitioned out. So we have a tree expanding out. Okay, so we want our nodes to start at the parent position. Giving them a class of node. And then just okay, so we're creating a new G element, we're adding the class of node, and then we're transforming it, translating it to creating the source from the original source, from the parent source, so y0 and x0. Okay, this can change. So when our children are clicked, their children start off at that position. So the source is what will be passed in there. So when you click the child of the original parent, then we're going to call this update again, but passing in that child, and then so its children will start at the position of the child that we've just passed in. Okay, so this is going to happen when we unclick, we're we're going to call a click function. So we're going to create a click function later on. Okay, so right now, that if we have a look, do we have anything on our page as of yet? Oh, blah, 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 blah. Select all. Okay, so click is not defined because we haven't defined it yet. Okay, do we have elements? We have our div, we have our container, we have our SVG, you can see there, and we have our G. So we have our nodes. We have our 5 nodes that have started already. There are 5 elements. So we had a parent who had 2 children, and one of those children had 2 children. So we have our nodes, but there's nothing there yet. There are elements that haven't been given anything yet. So, and you can see our SVG on the page as well. Okay, so you can see the height and the width of that. Okay, so we want kind of circles are the usual thing for nodes, aren't they? So that's what we had at the start of our graph. So we're going to create our circles. So node enter, dot append. Sorry, I keep switching between double. It doesn't matter, double quotes or single quotes. Circle, we'll give it a class of node. We'll give it a radius of 0 and a style. Fill, we will do a function. So return d dot underscore children. So if it has children, it'll be red. If it doesn't, it'll be black. Okay, this is a ternary operator in JavaScript. So this is the equivalent of doing if d dot children red else black. Okay, so that's what this does here. So that would be if return red / return black. So we have condition on the left here, and then on the right we have the expression that resolves. So if this is true, the left hand version takes place. If this is false, the right hand takes place. Okay. Do we have our nodes now? Will we have a look? We do not. Okay, we have a radius of 0. Dot append circle. Okay, we'll continue on anyway. So, okay, we're going to update. So var node enter dot merge node. Okay, so we're going to do a transition now. So we start our nodes at their parent position, but we want them to move to their new position. So node update dot select. So we're going to select the circle.node, which is this guy here. Okay, that's a g.node. This is a circle.node. So we're selecting circle.node. We're setting the radius to 10 and style we're sorry, we're not setting a style. Apologies, not just yet. We are setting a style. Sorry, of course, yeah, we're setting the same style. Okay, no, we're not. Sorry, I'm getting ahead of myself here. We have not transitioned yet. So node update, we're going to transition the node first. Okay, so like I said, transition from parent, starts at the same spot as the parent, moves out a little bit. So we want to transition. How long is the transition going to take? Remember, we set the duration variable up at the start of our code earlier on, so it's going to take that amount of time. So, and then where is it going to transition to? Transform. We have a function, and then so we started our first up here, started at source x, y0 and x0. Now where are we going to? We are going to translate to D, the new positions. So this node's position. So d.y plus d.x. Okay, then we're going to add our circles. Going to add a radius. So it's going to grow from a radius of 0 to a radius of 10. We're going to give it a style. So similarly, if the child has children, there we go, red and black. And so when you hover over it, we'll do cursor pointer. Okay, so next we're going to need to store the old positions for transition. So transition from one position to another, we need to store the old positions for to transition back. So if we want to collapse our graph, so d.x0 is equal to d.x, and d.y 0 is equal to d.y. Okay, we're going to need a click function as well. To trigger, so when we click on our nodes that they run. So if it has children, set the new variable d._children is equal to d.children. Now, so this, when we click up here, when we click on our nodes, that will call this function. So, and it will set up the children for our node. So it just loops through and checks if the new nodes have children, and to set those up and to let the code know. And then we call update D. So this calls this function again. So our graph updates and sets up the data for each forthcoming node. If we check our page here now, we have our nodes. So, okay. So we can click on them. You can see the ones that have children. This one has two children here, When you click on it, it goes red. When you click on this one, it goes red. But we're not getting rid of our nodes. We're not collapsing our nodes. So we've expanded them, but we haven't done anything to collapse them. So you can see at the start there the way they expand out. So that's our duration going. They started at, say if we set a duration to much slower so we could see what's going on. So set it to 570, so we set that. You can see what's going on there. They're expanding, they're all starting from the same parent position and then they expand outwards. We can style these now as well with CSS. So we'll go into our CSS here and just style. So our node circle is going to be white on the inside with a stroke of steel blue. We're going to have some node text and then we're going to have some link as well. So if we check that out now, our fill is okay, our fill is black, not white. Because we changed it in our code. So if we change this to same as our CSS, now we're moving along. Okay, so we have our click, our nodes are updating, they're on the page, but we need to get rid of them. Okay, when you click back, we kind of want these nodes to fade in. Okay. So for that we have a node enter, but for that we're going to use a node exit. So remove any existing nodes. So node exit is equal to node dot exit dot transition duration, same duration on the way back as well, and then our transform. So again we're going from, on exit we're going the opposite way, and we're not going from parent to child, we're going from child to parent. So again we pass in our datum, our node, and we return translate and we're going to go source dot y and source dot x and dot remove, which will remove it from the page. Okay, so that will remove the node. Now we need to remove the circle. So node exit dot select all, no, dot select circle, and we'll set the radius back to 0. So it starts at 0, goes to 10. When we click again, goes back to 0. Okay, so check that out now. Now we have our nodes expanding and contracting from their points, as they should. I suppose if we want text to explain what the data is, we're going to need to do that again. Do the same thing, add the text to the node, take the text, add labels to the node, take the labels away then when we click on them. So node enter dot append text. Where is it going to be? What size is it going to be? All these values that we need to pass in. and whether it has children or not. So the text position, it'll be on the left if it has children and on the right if it doesn't. All subtle ways to highlight if, just highlighting different parts about your data. You know, if it notes a child, it's a certain color. If it doesn't have a child, it's a different color. If it has a child, the text is on one side. If it doesn't have a child, the text is on the other side. You know, small little things that can make a difference within your graph. We have a text anchor as well. Again, always basing these on the data. You don't have to, but hard coding values like this into your code isn't always the best idea. So if it has children or underscore children, and then the actual text to put in. Again, a function, and we're going to return the name of the so our first data would be tree data. If normally if you were passing in this data directly, it'd be d.name, but when we put it through the hierarchy, it wrapped our function, so our data, it's actually d.data.name, because that's where our original data lies. So we go back to our graph, we refresh our page, and we can see now. Okay, so if it has children, the text is on the left. If it doesn't have children, the text is on the right. And if we are removing the text, node exit, select. Style. So we can just cover up the text or set the style to 0 so the text disappears. Okay, so now we need the links. Okay, we have our nodes, we have our text on our nodes. Now we need our links. So to join our nodes together, we are going to need a path that runs between one node and another, a function. So not just a straight line, but a kind of a fancy line. So we're going to create a function called diagonal. Okay, it's going to take two values and it's going to map a path between those two values. So path is an SVG element. It's used for drawing lines, but these lines don't have to be straight lines. They can be pretty much anything. So we have a template literal here. So I'm going to go so we're going to start s.y, source.y, source.x, I'm going to move to C. So then we're going to go part of the way, we're going to go source.y plus destination.y divided by 2 and source.x. We're going to go source.y plus d.y divided by 2 d.x, and then finally we're going to go d.y and d.x. Okay, so this will just, we pass it in the source node, the destination node, okay, and then we just draw a line between the two. Okay, and we return our path. Okay, now we can create our links. So for our link is equal to svg dot select all path dot link dot data links. We haven't created our links yet, have we? No, we created our nodes, so we need to create our links as well. Similarly, where are we? So we need for our links is equal to tree data dot descendants dot okay, pass in dot data links. And what to do with them. Returning the ID from the link. And again, similar to node enter, we'll create a var link enter. Dot enter dot insert. So we're not appending, we're inserting here. So path G class of link and HCDR of D, so we're going to pass in function D here, and okay, so var o is an object, x is source dot x0, y source dot y0. And then return diagonal well, okay, we're going to need to merge that as well. So for link update is equal to link enter dot merge with the link. Again, we're going to need transition. So link update dot transition dot duration and it's going to transition, so from its spot to its parent spot. So source and destination. Remember here in the path, so that will get the x and y coordinates from each of the nodes and then create the diagonal between them. And then of course we're going to need a link exit as well, so that when we click and remove everything, the path removes as well. Transition duration Control.remove. Okay, so our link on exit will transition, migrate duration, and the path then will be set to itself. So 0, 0, the object, so there is no, the source and the destination are the same, so there's no path between them. Okay, if we go back to our page now and we can check it out. Okay. Okay, and of course our paths and links aren't showing because we have a typo. Console, handy thing, working with JavaScript, tell you what the problem is. So here we have a typo, go back, try again. Now we have our links, our paths going from one to the other and collapsing. Just to show, earlier on we said the depth here of the nodes. So if we remove this, just to give you an idea, so it changes the depth. So they take up the whole graph, the nodes. So depending on how you're doing, so it's much nicer to create a depth and set a certain depth on the nodes. So you can check, each node has a depth on it. You can check that within the data itself in the console. You can see here that they have a depth, so one depth of 1. Yes, and a depth of 2 here. So that just creates 180. We were multiplying the depth by 180, so that means these are stuck here at 180, and then these ones are at 360. Little things like that make a difference in your graph. The example page, once again, documentation is great. The example page is here. There are examples if you need to go and look at stuff and just work through it, figure it out, read the documentation, and you should be good. So we now have a tree graph. We've put back in our depth. We have nodes updating, links updating, paths updating, and this will work if you have 5 pieces of data. 1, 2, 3, 4, 5 pieces of data, 5 nodes or more. You just pass in your other data. And like I said at the start, D3 is for custom visualizations. You won't get tree graphs like this. You can customize them any way you want. You can go with other charting libraries, of course, you know, that they're easier to start up with, that they have bar charts there, they have pie charts there, they have other charts there. But if you're looking for customization or changing things the way you want them, D3 is the way to go. Thank you very much. I hope that was okay and understandable, and I'll see you again. Thank you.